Good morning, guys. So today I'm gonna answer some question and solve some problems. So first, let's go with the question. So question 1, part 1. So draw the flow of a DC generator. So this is the flow of a DC generator. So we have mechanical power input and power developed in armature and electrical power output. So in the figure of a power flow diagram of a DC generator, it is shown that initially the mechanical power is given as an input which is converted into electrical power, and the output is obtained in the form of electrical power. So for example, kanang generator, so kanang kuan generator butangan nimo gas, mugana siya, kanang muandar siya. Yang kanang generator muhatag na natog electricity from mo kuan nga from mechanical to electrical. So nasa na yung mga losses. So the iron and friction losses, so between mechanical power input and power developed in a mature kanang contact sa mga bearing, and kaning copper losses sa power developed in armature and electrical power output manay loss nila kanang copper losses. So part 1, number 2. What are the two methods in improving commutation? So explain each for one sentence. So the two method is resistance commutation and the voltage commutation. So in resistance commutation, it improved by using carbon brushes and increase resistance. So in voltage commutation, it is made to induce a voltage in the coil undergoing the commutation process, which will neutralize the reactance voltage. So question number 3. What refers to the change in the terminal voltage between full load and no load? So it refers to voltage regulation. So because in the terminal of the generator in no load, it is higher than the voltage terminal if there's a full load. So number 4. So enumerate the 5 reasons of operating the generators in parallel. So number 1 is parallel operation of the alternator reduces the operating cost and the cost of energy generation. So number 2, it ensures the greater security of supply and enables overall economic generation. So number 3, if there is a breakdown of a generator, there is no interruption of the power supply because they are many power supply. So number 4, several alternators can be supplied a bigger load than a single alternator. So the last one is when one of the machine is scheduled maintenance, the other machine maintain the continuity of the supply. So number 5 is what are the requirements in order to successfully operate generators in parallel? So the requirement is frequency, phase, and the voltage must be the same, and equal load must be carried by each machine. So now let's go to the part 2, solving. So number 1 is two shunt generators are operating in parallel and taking equal shares of a 2400 amperes and 230 V bus load. The rating of the generator are flow percent regulation. G1 is cos 3 and G2 is 4%. So kilowatts rated power. So G1 is 500, G2 is 600. So rated voltage V, G1 is 250, G2 is 250. If an additional 600 A load is connected to the bus, determine the current delivery by each generator at this condition. So generator 1, So delta I rated 1, so P rated 1 over V rated 1, so equals to 550 500,000 over 250, so equals to 2,000 ampere. So generator 2 is delta I rated 2 equals to P rated 2 over V rated 2, so 600,000 over 250 equals to 2,400 ampere. So find the delta I 1. So delta I 1 over delta V equals to percent voltage regulation V rated 1 over I rated 1, so equals to 2000 over 0.03, since 3% man, times 250, so delta I1 is equal to 266.66 or 0.67 delta V. So find delta I2. So delta I2 over delta V equals to percent voltage regulation V rated 2 over I rated 2 equals to 2,400 over 0.04, okay, 4% man, times 250. So delta I2 equals to 240 delta V. So delta I plus delta 2 equals delta I. So 266.67 delta V plus 240 delta V equals to 600. So delta V is equals to 1.184. So the IG1 equals to IG2 equals 2,400 over 2 equals to 12, so equals to 1,200 ampere. So I nu 1 equals to 1,200 plus delta I equals to 1,200 plus delta plus 266.67 times 1.184. So I nu 1 is equals to 1515.74 ampere. So I nu is equals to 1,200 plus delta I2, so equals to 1,200 plus 240 times 1.84. So I nu 2 equals to 1484.16 ampere. So problem number 2. A long shunt compound generator has the following parameters: RA equals to 0.1 ohm, RSE equals to 0.05 ohms, and RSH equals to 120 ohms. This machine supply power aggregate DC load of 10 kilowatts. At this load, the armature generator generates 246 volts. Determine the terminal voltage. So natay formula nga IA is equals to IL plus IH. So first we need to find the IL and the IH SH, or the I shunt. So find the IL first. So IL is equals to PL over VL, so equals to 10,000 over VL. So ang I shunt equals to VL over RSH, so equals to VL over 120. So IA is equals to IL plus ISH, so substitute. So 10,000 over VL plus VL over 120. So let's go to the next formula. So next formula is EG over L equals to VL plus IA times RA plus RSE. So natay 246 nga 246 nga volts, so equals to VL plus ang IA na to kay kani siya, kani og kani una to ang IA, so 10,000 over VL plus VL over 120, so times 0.1 RA mo ng RA, yeah, 0.05 mo ng R is E. So 246 equals VL plus 10,000 over VL plus VL over 120 times 0.1 plus 0.05. So ang kaning IA na to o kaning RA plus R is E, ato na siya in time, so makuha na to ang 246 equals VL plus 150 over VL plus 0.00125 VL. So para makuha ning VL kaning nasa ubos denominator, ato na sila times san og VL. So 1.00125 VL squared plus 1,500 minus 246 VL equals to 0. So VL is equals to 239.44 volts. So number 3, problem 3. So a 4-pole DC generator with duplex lap winding has 48 slots and 4 elements per slot. So the flux per pole is 2.5 times 10 to the power of 6 Maxwells and it runs at 1,500 RPM. What is the output voltage? So first ato pangitaon ang given. So natay formula kani, ato formula kay EG equals to PNZ flux over 60 over A. So ato na sila pangitaon. So ang P na to kay 4, so ang N kay 1,500 RPM and ang Z kay 48 times 4 equals to 192, since kung ano siya 48 slots and 4 elements per slot, so 48 times 4. So the flux kay 2.5 times 10 to the power of 6. Yeah, ang M na to kay 2. So ato na silang i-substitute. So natin formula nga PNZ flux over 60 MP to the times 10 to the power of negative 8. So P kay 4, ya ang N kay 1,500, ya ang Z kay 192, ya ang flux kay 2.5 times 10 to the power of 6 over all over 60 times 2 times 4, so times 10 to the power of negative 8. So the answer is 60 volts. So let's go to the problem number 4. So a separately excited generator when running at 1000 RPM supplied 200 ampere at 125 volts. What will be the load current when the span drops to 800 RPM if the current field is unchanged? Given that the armature resistance is 0.04 ohms and brush drop equals to 2 volts, so we have the formula of EG of equals to IA times RA plus VL plus VBR. So EG equals to 200 times 0.04 plus 125 plus 2. So Eg1 equals to 135 volts. So another formula equals to Eg1 over Eg2 equals to flux 1 and 1 over flux 2 na kani flux 2 and 2. So let's assume that flux is constant. So Eg1 is 135 over Eg2 equals to 1000 over 800. Eg2 equals to 108 volts. So let's proceed. So 108 equals to IL2 times 0.04 plus RL times IL2 plus 2. So RL is equals to 125 volts over 200 amps. So equals to 0.625 ohms. So 108 equals to IL2 times 0.04 plus 0.625 IL2 plus 2. So ang IL2 equals to 159.4 amps. So number 5, so a DC machine running at 500 RPM, the hysteresis and the ED current losses are 250 watts and 150 watts respectively. Find the speed at which the core losses are reduced by 30%. Assume flux is constant. So natay formula nga P core equals to P ED plus P hysteresis, and it is also equal to AN squared plus BN. So we have PED or 150 watts and P hysteresis is 250 watts. So let's go find A. So to find A, we need PED equals to AN squared. So PED kay 150, so 150 and equals to AN 500 squared. So A equals to 0.0006. So sa B na sad, so P hysteresis equals to BN. So ang P hysteresis kay 250 and equals to B times 500. So B equals to 0.5. So let's go to the core. So P core equals to PAD plus PN, P hysteresis day. So 150 plus 250 times 0.7, which is 70%, kay naman diri nga reduces by 30% man. So 100 minus 30, so 70%. So 0.7, so equals to 280. So 280 equals to 0.0006 n squared plus 0.5 n. So let's convert to 0. So 0.0006 n squared plus 0.05 n minus 280. So we get n equals to 383.51 RPM. So now let's go to the number 6. So a Longchamp compound generator supplies a 100 amp at a terminal voltage of 250 volts. The resistance of the armature shunt field and series field are respectively 0.02 ohms, 50 ohms, and 0.05 ohms. The bhp of the driving engine is 38. So calculate the stray power losses. So yeah. So natay formula nga PO equals to VL IL. So natay VL nga 250, natay nga IL nga 100, so equals to 25 kilowatts. So let's go to the IF. So IF equals to VL over RF. So we have VL nga 250, nga RF kay 50. So equals to 5 amperes. So IA IA. So IA equals to IF plus IL. So we have IF of 5 and IL kay 100. So equals to 105 amperes. So let's go to EG. So EG equals to VL plus IA times RSE plus RA. So equals to natay VL nga 250, nya IA kay 105, nya RSE plus RA kay 0.05 plus 0.02, so equals to 257.35 volts. So arin na ito sa PDEV. So PDEV equals to EG times IA. So nata EG nga 257.35 ato na times sa IA nga 105. So makuha na to ang 27,021.75 watts. So nanatay PDEV. So makuha na nato ang P stray. So in order to get the P stray, we have the formula of BHP times 746 equals to P stray plus PDEV. So natay BHP nga 38, nya ang kaning PDEV na to kay kaning 27,021.75. So kaning 27,021.75 ato na siya ibalhin diri. So minus na ang kaning 38 times 746 minus 200 out of 27,021.75. So makuha na to ang P stray equals to 1,326.75 watts.